Hi, welcome to the demo of Dell CSM Resiliency module for PowerStore. My name is Anuraj. I am an engineering technologist with Dell. The CSM Resiliency module with the release of 1.6 now supports the Dell PowerStore array. The CSM Resiliency module is designed to make stateful Kubernetes application more resilient to various failures such as the node failure, control plane failure, means the kubelet on the worker node is failed, or there is a control plane network failure where the kubelet is not able to reach to kube API server, or there is a storage IO failure where the worker node is not able to reach to the storage array. So in all these failure scenarios, the CSM resiliency module help us to make our stateful application more resilient. And when we enable the CSM resiliency module, the CSM resiliency module is installed as a sidecar to the CSI driver pods. And once we enable the CSM resiliency module, we have a granular control per pod to enable this module or not. And we'll enable this using a label, and the label name is podman.dellemc.com/driver, and the value of the label depends on which array we are going to use. In the case of the PowerStore array, the default value will be CSI-PowerStore. For this demo, I deployed a small Kubernetes cluster with 3 worker node and 1 control node. And this cluster is already integrated with a PowerStore array. And the integration is done using the CSI driver, and the CSI driver is running in the CSI-PowerStore namespace. During the installation of the CSI driver, I already enabled the CSM resiliency module. We can see the CSM resiliency sidecar is running inside the driver pod. And the sidecar for the CSI resiliency module is called the podman, and we can see the sidecar running inside the CSI driver pod. Also a storage class named sc-PowerStore-RWO is also created, and this storage class will help us carve out the read-write once block volume from the PowerStore array. Now we will try to simulate a node failure, and we'll see how the CSM resiliency module help us to recover from the node failure. So for this purpose, we'll create 2 different stateful sets. One stateful set will be monitored by the CSM resiliency module, and the other one will not be monitored by the CSM resiliency module. I already created the YAML specification for 2 different stateful set. So let's look into the YAML files. This is a very simple stateful set which is running a busybox pod, and the pod is writing the timestamp, node name and pod name into a file in an infinite loop. And this file is actually a mount point where the PVC from the PowerStore is mounted, which we can see here. The second stateful set is also exactly same as the first one, except this stateful set is labeled with a label podman.dellemc.com/driver, so that the resiliency module will be monitoring this pod. Now let's create these 2 stateful set and wait for the pods to be in running state. Also verify the PVC. So we can see the PVCs are created and they are in bound state. Now we can verify the label on the pods. So now we can see out of the 2 pods running, only 1 pod has the label. So the CSM resiliency module will be monitoring only the pod which is sts-busybox-resiliency. Now let's find out on which node these pods are running. Now we can see both the pods are running on the node 2. Now let's go ahead and shut down the node 02 to simulate a node failure. And these are virtual machines. So let's go to a vCenter, then hard power off this virtual machine to simulate a node failure. Wait for the node to go down. And by default, Kubernetes will take up to 40 seconds to detect this node failure and to mark the node as not ready. So let's wait for the 40 seconds. I'll pause the video. Now almost after 40 seconds, the node is marked as not ready. Let's run a watch on the pods. And the pod is showing as running because the kube API server is not able to get the status from the kubelet, and the kubelet is down. By default, the Kubernetes will wait for up to 5 minutes before marking the pod as terminating. So in the case of stateful set, Every pod is uniquely identified, so the Kubernetes cannot have a duplicate pods running. So the Kubernetes will wait for the pod to be terminated before creating a new pod. And in this case, the pod cannot be terminated completely because the cleanup has to be done by the kubelet and the node is down. So what's going to happen is the Kubernetes is going to wait indefinitely for this pod to get terminated, and we are going to have a service outage here. But in the case of the pod monitored by the CSM resiliency module, the CSM resiliency module will detect the node failure and helps to bring back this pod onto a healthy running node. Now I'll pause this video here, and almost after 3 minutes, that is the default timeout value for the CSM resiliency module for PowerStore, we can see the pod monitored by the CSM resiliency module is getting recreated on a new node. Now we will wait for a couple more minutes for the Kubernetes to mark the other pod also terminating. Almost after 5 minutes, the node is marked as not ready. Now we can see the pod is marked as terminating by the Kubernetes. And now it requires an manual intervention from the administrator to do a recovery depending on the kind of failure. Also, we can see the pod monitored by the CSM resiliency module is already running. So this concludes this demo. Thank you for watching. I hope you enjoyed the video.